So, let's talk Dura Ace. Hydraulic brakes failure. In recent days, I got some complaints from the owners of the latest Dura Ace hydraulic brakes that the problem is they don't want to retract the pistons back inside as it should supposed to be. So the brake is already overheating like it was the illness in the previous SRAM Guide Air RLC level and all the kind of similar brakes. Now the problem is just a little bit of history and my personal experiences about it. In the past, all the brake calipers, they use some kind of, let's say, universal plastic engineering plastic materials for the pistons. And as we all know, they didn't work so well because when you overheat the system, it kind of caused the formation to be truncated, so like in trumpet shape. So it didn't want to retract inside anymore, despite you have the viscosity forces, which because the liquid, if there is no air inside. And then they start to use ceramic, and they thought we will solve this problem very easily. So you have very high resistant, heat resistant material. Coefficient of thermal conductivity of ceramic material is very, very low. But in this case, you didn't solve much problems. Why is that? So just imagine that you have a small candle which you usually put on the table in diameter, maybe, I don't know, 30-40 millimeters. And then you try to warm the place with that candle. It will be very hard, right? Yes. So imagine that you cover that with some kind of ceramic pot, and suddenly you start to feel how you're heating the place, that room that you have that inside. So the point is that if you have ceramic material with a high resistant heat resistance, it means the heat mass sooner or later will accumulate the heat a little bit slower than any other material. But the problem is this material will cool down also very, very slowly. So if it cools slowly, that means any additional braking. Imagine that the disc brake, the pair of brake pads and disc brake when rotating and braking is the candle. And that candle is heating up this surface. Why it happens? It happens that it starts to melt the inner in here on this piston. You see it's very rough. It's rough surface, which is very, very inconvenient for the sealing pair. So what is happening when you overheat this, like that candle is heating the pot over that? Any additional, when this is already, let's say, at 200 degrees Celsius, any additional braking will overheating the system all over the time. So start to melt the seal inside this gasket. So the problem is all this black color that you see in here is basically the fingerprint of the seal. And it actually sticks together so much because it's a rough surface that it was to eject out of the caliper, I need at least 10 bar. 10 bar. It was so glued together with the seal. And in all my let's say life experiences in my personal construction of pistons, which even in this case I already have prepared the prototype, which have in here the conical surface. Why it's conical? Well, the conical surface is because when I built the prototype or any kind of piston, I put the piston on the electric cooking plate, heating up to 200 degrees with special devices. It's not special device, it's just a simple Lettier. I'm just going to show you. This is how I measure. This is how I measure the temperature on the piston. This is the connector for MPN and PNP pairs conductor, and this is this tiny 2 wires. I don't know if you see quite good. These are 2 wires together, which I actually screw inside of the piston, and I measure the temperature with the voltmeter, which has linear characteristic inside, and I can see what's happening with this conical shape in here. So the shape of where this conical surface starts, is it at 5 mm, 6, depends on the geometry of the piston. So I know if I overheat at 250 degrees, which is actually already exaggerated, I want to see that my pistons are not, elongate or extrude over the 0 degrees above the level. So that means the maximum deformation that I allow to my pistons is go up to 0 degrees. That means it becomes straight on the entire surface. Another thing is also that I'm using different materials, which means they're heating faster. As well, in here we can see these separated sections. This is the surface that it's in contact with the brake pads. In this case, you can see the surface for the contact is much more higher. So that means the heat flow from the back plate of the brake pads is much more higher than in this case. So this is still in prototype phase. Next week maybe I will already have the proper geometry of the pistons, and then I'm gonna install back to the caliper. And of course the owner, it's the owner of the bike shop which gave me this. This is actually from brand new bike. I don't know how many miles have on it. And they will do the test, because I don't have so much money to such an expensive bicycle with the hydraulic disc brakes system on it. So other people will have to test instead of me. So I'm just waiting for the feedback information, but ceramic materials, it's no go, because like I said, with the small candle you can heat up to 20 square meters of place if you cover it with the ceramic pot with some holes on it, because the heat resistant material will accumulate heat very, very slowly. But when it fills, let's say, to the saturation of the heat mass is 100%, then start to emanate to the surroundings, and then you can just have a small additional heat which is coming from the candle, will constantly heating the place. So I imagine that this piston in here is like that pot over the candle. I hope the philosophy of my piston prototypes, philosophy of how to create something and design is much more complicated than some people think. Piston you put inside and it works. It works, but no one on this planet, I think, doesn't do the test. What is happening with the piston if you're hitting it on 100, 200 degrees, how the deformation of the piston looks like. And I can measure directly. If I put on the electric plate, I measure every second what is happening with the conical surface, and is it straight right away, is it straight at the end of the heating procedure, or how it goes. So this story will be very interesting. This is kind of a challenge for me, and we'll see how it goes. So this is the first part of the clip, so don't forget to subscribe, and you will catch up also the second part. Cheers. Bye.